Hi, teardown time again. Might be looking a little bit dark today. The reason is what I'm going to be looking at is this. This is the Microvision laser pico projector. This is currently just displaying its own test image. This is a very interesting little unit. I've played around with pico projectors before, like the DLP based ones. The problem with those is their depth of focus isn't particularly good. The thing about this is actually doing laser raster scanning, which means that because it's a very fine beam, there's no focus issues. So I'll zoom in on this a little bit so you can see it a bit better. Pretty much any distance it stays in focus, but also it means that you can do weird geometries without worrying about focus. You can even sort of project it onto weird shaped surfaces to get all sorts of funky stuff happening. Big lens, and you can do some sort of slightly funky image bending. There's a fly eye lens out of that big NEC projector I took apart. Gets a bit psychedelic. Another thing, because you don't have to worry about the focus, you can use a mirror to bounce the image, so I can sort of bounce the image off a mirror. So if I wanted to, say, scan the image around the place, I could maybe use a little servo operated mirror to do it. So yeah, quite a funky little toy. Right, we've taken the first cover off. One thing that's quite noticeable, there's a lot of shielding in here. It looks like it's metallised plastic, but there's also what I think is aluminium foil here with a lot of these thermally conductive pads to conduct the heat away from the board out to the case. Again, there's another one in here. So what we can see here, there's a big Altera Cyclone 3 FPGA, and there's a Microvision custom chip on here, a crystal oscillator. This is all going to be power supply circuitry. There's a flex, this goes around the back of the battery. This is just the I/O connector, and there's a little jack socket there. Let's see what's under this foil. Again, this foil is, not sure if this is shielding or thermal or both. Looks like it's shielding actually. We've got plastic housing for the actual laser and optics assembly, some flex coming up onto the main board, another little heat conductive pad for that chip down there, and some more screws. One little tip, when I'm taking stuff like this apart, what I tend to do is each set of screws, like say the screws that take the cover off, I'll put in one cup, and then when I start going to the next level I'll stick the screws in a second cup. So the worst thing is you end up with a big pile of screws all different sizes. At least if you keep them roughly in order, you at least know which set of screws goes roughly where. So you tend to end up with slightly fewer left over at the end, but I mean they always put too many screws in these things. Let's look at it. So this is the laser module. Looking at here, it looks like we've got a couple of laser diodes. Let's get these buttons out of the way. I'm guessing there's probably two laser diodes here in a larger assembly. This is probably going to be a DPSS laser for the green. They've not really got single diode green lasers yet, so my guess is we've got red and blue diodes there and a DPSS module there. It's very small. The actual whole optic assembly is pretty small. That's maybe what, 40mm by 20mm. In here we've got the little scanning mirror. There's a little, it's like I believe it's a silicon micro machine type thing with a single mirror that scans the laser beam over a raster scan to make the image. Yeah, we've got some high density connectors connecting the laser module. Let's carefully ease that off there. Very close. No. Checking this flex. Alright, okay, so we've now separated the laser module from the PCB assembly. Let's see what else is on this PCB assembly. This is a sandwich of two PCBs. I've got a spacer falling out there. Oh, lots of spacers. Right, so there's not much more to see on here. Yeah, this bottom one looks mostly like sort of interconnects. There's a few bits and pieces on it, but not a great deal. This looks like the more interesting board. So we've got masses of decoupling caps for the FPGA on this side. Another Microvision custom chip, a couple of chips here. There's probably going to be a flash ROM and a RAM on there. SGS Thompson, there's a serial SPI flash there. That's probably going to have the firmware in it, I should think. Alright, this is just a video switch, this chip. So that's probably handling the composite video input. Yeah, it's just analog switch chip. What else have we got? Right, this is an Intercell ISL 98002, which is a video A to D converter, so this is going to be handling the analog inputs. So I assume this thing's got a VGA analog, it's only got a composite input to this, and so this is where all the funky stuff happens for driving the projector. There's some power supply components around here. Yeah, so basically most of it's an FPGA, 2 custom Microvision chips, power management, and RAM and ROM. These, I'm guessing those are probably both DRAMs for frame buffering. So yeah, so that's the electronics out of the way. Again, here it looks like this is coupled to some metal foil for probably heat sinking for the lasers. Don't think we can really get into that optical assembly without doing some serious damage. I'll keep an eye out for a dodgy one on eBay, a faulty one on eBay to pull to pieces, but just looking at this, this is all probably all bonded and screwed together, so that's not something that you're going to be able to get back together again after it's been taken apart. So as this isn't my projector, I think I'm going to leave that, but say that these flex, these tiny little high density connectors on there. So this, yeah, this laser's quite a lot better. So looking at the positioning, it looks like you've got the 3 lasers coming in here. There's probably going to be a beam combiner to get the laser onto the mirror that then projects the beam out. And so this here is almost certainly a green DPSS here. So yeah, I think that's about as far as we can go on this at the moment. Sorry. Another clue to the laser type, this warning stickers here that says class 3B visible and invisible laser radiation when open. The invisible would be the pump laser for the DPSS, the normal green laser. It's an 808 nanometer pump diode pumping a 1064 nanometer solid state laser that then gets frequency doubled up to produce the 532 nanometer green. There's a front window there that I can see, but you can't see it in the camera, but it does have some coating on it. So that may well be doing some infrared filtering too, because a lot of green lasers do actually produce a reasonable amount of infrared output that doesn't get doubled by the frequency doubler, so there's probably a bit of filtering to filter that off. That's actually one of the dangers of the really cheap, crappy green laser pointers. They can actually put out quite a nasty amount of infrared that you don't see. So a little bit surprised they've used wires to connect these and not flex PCB. And on a product like this, I'd normally expect you just to see all this done on flex, because obviously these wires take a certain amount of manual work to solder them. So I was a little bit surprised by that. Something I just noticed on the front of this optical block. There's a little component down the front here. Now, looking at where it's positioned, my guess is that's actually monitoring the optical output from the laser, because it looks, I can see there seems to be like a light pathway coming down from this direction, so that's probably going to be a photodiode for monitoring the laser output on the front there. Right, just powered it up, check it's still working, and yes, we have some projection there. Interesting, there's a couple of LEDs on the PCB that aren't actually visible through the case. There's no holes in the case for those to shine through. There's a couple couple of light guides that shine these through the make those peep through the side, but there's actually a couple of LEDs that I don't know if those for debugging or something, but just flashing away inside. This is just the power up hinge. When you just turn the thing on, it has that built-in image just to do a quick demonstration. Right, one of the reasons, apart from pure curiosity, for taking this apart was just to see whether you could actually make this thing any smaller. For some, we've got a few ideas for some installation applications for this. So it looks like you could probably chop the whole battery area out and just fold this input board over, and maybe you could do a double fold so you could actually put the cable in there, so you'd actually maybe cut the length down to perhaps 60% of what it was at the expense of a little bit of thickness. So possibly has a little bit of potential for some playing. You'd have to figure out a way to fudge the on-off switch though, like a lot of these consumer products. I had the same problem when I was looking at the one of the DLP picker projectors. You want something just to apply power and it will just come on, but this you've always got to press the button. But I'm sure ways could be found to get around that if necessary. There's even a little bit of space behind there. You could get a little board to do that if you really wanted to. Maybe just replace these boards with something that just gives you a little contact closure or something on power up. Let me also just notice there's another little flex connector in there, so I'm guessing that's maybe an option for a slightly different product, or a product that's got maybe an SD card slot or something on it. Right, that's it back together, and look, no screws left. That'll be a first. Stick the battery in and see if it still works. Got the light on. It takes a few seconds to start up. If you look carefully, you can actually see the mirror starting to wobble a little bit before the lasers kick in. I'm not sure if you can see that. We've got a bit of a wobbly mirror in there. Yeah, you can just push it, and the lasers are on. And yeah, it's still working. We'll just have a look to see if there's much processing delay on here. What I've done is I've connected the projector up to the video camera's output, so this is actually showing what the camera's showing. I'll zoom in a bit. So it's now doing the sort of classic video camera feedback thing. Picture of a picture of a picture. This is quite a good way of testing the delay through a system. It's actually pretty quick, so there's not much processing delay. On some systems, internal processing, there's a bit of delay in there, so you sort of flip it and you get the effect disappearing through the back. So there's not a great deal of sort of frame buffering or anything going on there. Right, I just want to have a look at the actual optical timings coming out of this. What I've done is I've connected a standard photodiode up to a scope, and I'm just going to point the projector at it and just see what we get. This is with its built-in test pattern. So we've got frame frequency at 60 Hertz, and then our line frequency is, okay, you can see some line frequency stuff here at, that's about 18 kilohertz. This thing's actually made by Microvision. It's got image by PicoP, and it's called a Showwx.